All right, class, in this lesson we are going to talk about reading and writing to files. This is not too dissimilar to reading and writing from the console, but it opens up a new world where we are going to be able to save information for the next time that we run a program. So it's not just while we're running the program, but next time we get to access that data again. We're going to be accessing .dat files. We can use this also on txt files and a couple other file types. But for now, we're going to keep it simple and easy with .dat files. Let's get into it right now. So reading from a file is it's very similar to reading user input. Similar to user input. And I should stress that there are multiple ways to do this, but the way that we're going to do it is the most understandable for our current knowledge with Java, and is going to run pretty stably with what we do. There are some more stable ways to do it, but this is going to work just fine for our use case. So we're going to use our friend import java.util.scanner. This is for writing to a file, so this is for writing to a file, and scanner is for reading. Okay, first things we need to note is that now we're going to have to do our input inside of the try statement. So we need to take in that data inside of a try statement because we can get certain kinds of exceptions when dealing with files. So we have to have those inside of the try statement. The next thing you're going to notice that's new is inside of our new scanner statement, instead of saying system.in, we now have a new file. And inside of new file, we have this little thing right here that is going to be the path to our file. So the path to the file. So what this means is that if we have the file, say, inside of folders in our directory structure, which basically just means our folder structure for the project, we have to write the names of those folders with the slashes in order to get to the file. And we need to include the file name and extension. So the path to the file and the file name and extension. Extensions with a T. So here my file name is out.dat, and you can see it up here on a tab, and it's in the same directory, so it's in the same folder. And when we start, that's the easiest way to do things. Just keep it in the same folder where all your .java files are. Keep your .dat file there. You can name it whatever you want. Just put it inside of quotes, file name and extension, saying new capital F file, and the name of the file that you're going to do there. And now our file is just like when we say scanner keyboard or scanner in, same thing. We have all of those methods that we had before. The next new thing that we have is this Hasnext method. We're going to say file.hasnext. And this checks and sees, is there anything left in the file? So it's going to continue reading until there's anything left in the file. Is there anything left? So as long as there's something left in the file, it's going to keep looping through. And what is it going to loop through? Well, it's going to take from our file, it's going to read that next line. Remember, we have our friend the scanner, all those methods from scanner, next int, next double, next line. It's going to read that next line, and then we're going to print it out to our console. So it's going to read from the document and immediately print it. We could save it to an array here. We could change it and format it into an object, do all different kinds of things that we need to do. But we're just going to simply print to the console. Next thing we're going to do, and so important, close the file. You must close every file. Close the file, because if we don't close the file, we can get corrupted data. Bad things can happen. The program will still run if you don't close it, but don't do that. Close every file. That way we don't get any problems. It can be a real problem when we get to reading and writing at the same time, so we want to make sure we're closing it when we're done reading. So we're going to close it. All of these can throw an exception when we're dealing with files, so we have everything wrapped inside of our try statement. And of course, our catch statement here says if there was an error, if there was an exception, then we're going to print out to our system.err, which is basically the same thing as system.out. It's just a little bit different and helps with error logging. System.err.println, there was a problem reading the file, and then we're going to get the message from our E object, our exception object. So that's as easy as it gets with reading from our DAT file. Okay, writing to the DAT file gets a little bit more complicated, especially when we want to append to a document. So when we want to add new information to a document, we need to make sure that we don't get rid of what is there. And in order to do that, we need our friend, the buffer writer. So the buffer writer allows us to hold on to that information and rewrite it back into the document. And so there's a couple of extra steps that we need to go through in order to create our buffer writer and eventually our print writer. So this is, we're going to call this pro forma. And what I mean by that is that we don't have to know what's going on here. There's a lot of information in all three of these objects, and there's a ton of methods in each one of them that we could spend an entire class just talking about these three objects here. But one of the beautiful things about object-oriented programming, we don't need to know all of those things. We only need to know how to use them based off the documentation. And again, this is beyond the AP, so we're not going to ask super complicated questions. So keep this as something that you're going to use a lot. You're going to use these three lines of code a lot. The thing you're going to change is just like up above, our new file.dat here, we're simply going to change the file name to your file. Whatever your file goes here, your file here. Everything else we're going to keep pretty much the same with this. You might change, if you want, you can change this variable name right here, but those are the only two things that you really want to change within these three blocks of code. So we're creating a file writer. That file writer is used to create a buffer writer, and the buffer writer is used to create a print writer. Okay, so the print writer is actually what does the work of writing to the document. So all that we have to do is, just like our system.out, we instead say our fileout.println. And this is why I like using fileout as the name, because it makes it easy for me to remember, is all I have to do is say fileout.println, and this will append, meaning adds on to the document. So every time I run this program, it's going to put on a new line, hello, exclamation point. And then, of course, we're going to close that file. And we have our exception handling down below with our catch statement. So let's take a look at this. Let's run this really quick. Let's take a look at it live in replit here. So here we are live in replit. Our DAT file is empty at the moment. So let's go back to our main file. We haven't done anything yet. We're going to click run and watch it run over here. And we'll see nothing happens. Well, that makes sense, right? Because our first time through here, when we read from the file, there's nothing in the file. But then we also had a write to the file. Let's look at our DAT file. Our DAT file's got something new in it. This is awesome. So now watch. If I hit run again, we watch our output over on the side here. And boom, now I've got an output of hello. There's my output. Awesome. But let's check our DAT again. Oh, it just added hello again on a new line. Let's run it again. Oh, now we got hello, hello. 2 hellos now. How many hellos do we have in DAT? 3. And it just keeps going on like that. And you can see it's going to add a new hello every time I run it. So now I have a program that keeps track of how many times I've run the program, in a way, because I have the number of hellos. This opens up a whole new world of possibilities for us for dealing with data, handling data. This, of course, is not a secure way to hold data. You don't want to hold anything like passwords or personal information this way, but it's a great way to get started with understanding how we can create programs that are persistent and that will hold on to things for a long time for us. All right, I'll see you in the next lesson.